In this video, I am going to show you how to solve quadratics by taking square roots. Now, in order for you to solve by taking square roots, you need to know how to simplify square roots. So we are going to review how to simplify radicals, simplify square roots in this case. Now, a radical is an expression with square root, cube root, fourth root, fifth root, and so on. Okay, but we're just going to mainly focus with square root in this lesson. Before we get into it, it's really important that you know your first 10 perfect square. Okay, because when we're simplifying square root, we're going to break up the non-perfect square into one of these numbers, perfect square. So what are the first 10 perfect square? The first 10 perfect square are these numbers right here. Okay, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, so these are your first 10 perfect square. Okay, when you take square root of these numbers, it's going to come out to a perfect number. So when we are simplifying square root, we're going to break it up using these numbers. Okay, so therefore it's really important that you know these perfect square. Okay, so in order for you to solve quadratic equations by taking square roots, you have to know how to simplify square root. Here we are going to review of how to simplify square roots. We're going to do two of these. Let's take a look at the first one. So simplify square root of 245. Now to simplify square root is to break this down into simplest form. Here's how we're going to do it. To simplify this, we're going to break the radical down using the largest perfect square. And then we're going to take the square root of that perfect square. And we're going to leave the leftover underneath the radical sign. In this case, it's square root. So we're going to break this down, okay, using one of those perfect square. We want to use the largest perfect square to break up 245. Because if you don't use the largest perfect square, then you will have to continue to simplify. So think of 245, largest perfect square that can go into 245. Okay, how about 49? Okay, can 49 go into 245? Yeah, that would be 5 times. So we would like to break this up into square root of 49, okay, times square root of 5. Okay, see how we broke it up, you guys? Okay, so square root of 49 times square root of 5 give us 245. Now square root of 49 is a perfect square. So when you take square root of 49, 7 times square root of 5. So that's how you break it down into simplest form. Okay, simplify square root of 245. We get 7 times square root of 5. Okay, let's take a look at another one. Okay, so here we're going to simplify 9 times square root of 45. The 9 is outside of the square root, so we do not work with that number yet. Okay, so we're just going to have to break this up. Square root of 45, think of the largest perfect square that can go into 45. How about we do 9 times 5? Okay, so we're going to bring down the 9. Okay, and then we're going to break this up into square root of 9 times square root of 5. Okay, so that's going to give us square root of 45. Now square root of 9 is a perfect square. Okay, so what is it when you take square root of 9? Well, when you take square root of 9, you get 3. Because 3 times 3 is 9. And then we're going to bring down this 9 right here. Okay, so 9 times 3. And then here's your leftover. Okay, so we're just going to leave that alone, okay? Okay, so here we have 9 times 3. Okay, so you have to multiply those two numbers. So 9 times 3 is 27, and then bring down the square root of 5. So we simplify square root of 45 into 3 times square root of 5, and then we multiply that by 9 to get 27 square root of 5. So you're going to have to know how to do this when you are solving quadratic equations by taking square root, because it's all going to come down, okay, taking square root of a number, and you have to simplify it. You got to break it down into simplest form. You can't leave it like that if it's not simplified. Okay, so you're going to have to know how to simplify radicals. So let's go ahead and take a look at some examples of how to solve quadratics by taking square root. Okay, so before we get into solving quadratics by taking square root, we need to look at what type of quadratics that you are able to solve by taking square root. Not all of the quadratic equations can be solved by taking square root. Okay, we need to know that when we see one, we need to recognize that, hey, this is a quadratic equations that I can solve by taking square root. Okay, so we're going to look at what type. Okay, so quadratic equations of the form a x squared plus c equals to 0. Okay, notice this is a quadratic equation, but it has no bx term. See how the bx term is missing? So you have the x squared term, and you have a constant. Okay, so anytime you have a case like this, you can solve it by taking square root. Okay, now if it has a bx term, then you have to use another way to solve it. Okay, and then we're going to get into that as this lesson goes on. Okay, but right now we're just going to focus on this type of the quadratic equation. So how do we solve something like this? So for an example, let's say we have x squared, okay, quadratic because it's x squared equals to n. So how do we solve this? How do we solve for x? Well, to get the x by itself, to solve for x, you need to get rid of the square. In order to make the square go away, you need to take square root of it. So we're going to take square root of x squared. Okay, and then we're going to take square root of n, right? So whatever you do to one side, you have to do it to the other side. So since we're taking square root on the left, we have to take the square root on the right. Okay, so when you take square root of x squared, you're just going to get x. And then now over here, square root of n, we don't know what n is, so we're just going to keep it like that. Anytime you solve an equation in this case, okay, you're going to need a plus or minus in front of your number. Okay, let me explain why you need that plus or minus. Let's say for an example, you have x squared equals to 4. So this one can be solved by taking square root. So how do I solve this? Well, first I would take square root of x squared, and then I have to take square root of 4. Okay, so to go from x squared to x, I need to take the square root. So square root of x squared is just going to be x. And then we know square root of 4 is 2 because 2 times 2 is 4. The reason why you need a plus or minus in front of this number, because look, go back to this original equation, okay? So if I plug 2 in, right? For example, let's say I plug 2 in for x. So if I put 2 in for x, okay, if I square that, because it's x squared, right? I'll get 4, okay, which is good. Now, if I put negative 2 in for x, and then I square negative 2, I'm also going to get 4, right? Because negative 2 times negative 2 is positive 4. Okay, so that is why you need that plus or minus in front of the number. Okay, so I hope that makes sense. We're going to get into examples where we're going to solve the equation by taking square root. Here we are going to solve this equation using the square root method. Okay, so let's see, are we able to do it? Well, we have an x squared term, and you have a constant, so there is no bx term. As you can see, there's nothing with an x term. So yeah, you can do it. Okay, you can solve this by taking square root. Okay, so how do we solve this by taking square root? We have a procedure here, step by step, of how to do it. Okay, so let's take a look at step 1. So step 1 is to isolate x squared. So here's your x squared, so we need to isolate x squared. Meaning, we have to get this x squared right here all by itself on one side of the equal sign. Okay, so how do we do that? Well, first thing we need to do is get rid of the minus 9 and then get rid of the multiply by 2. So to get rid of the minus 9, you want to add 9 to it. So if you add 9 to the left, you have to add 9 to the right. Okay, so here we're going to bring down the 2x squared. Okay, now negative 9 with positive 9 is gone, so they add up to 0. We're going to bring down the equal sign. And then we have to add these two numbers. So because they're both positive numbers, 55 plus 9 is going to give you 64. Okay, so we got rid of the minus 9. Now we have to move on by getting rid of multiply by 2. Okay, you see how you have 2 times x squared? So to isolate x squared, you need to do the opposite of multiply, that is to divide. So we're going to divide by 2. So if you divide this by 2, you have to divide the 64 by 2. 2 over 2 is 1, right? So you're left with just x squared. So we're left with just x squared on the left hand side. And then on the right hand side, 2 goes into 64. What's half of 64? 32. Let's move on to step 2. So step 2 is to take the square root of both sides. Okay, so we're going to take the square root to get rid of the square. Okay, so we're going to take square root of x squared. Okay, you need to get rid of that square. And you have to take square root of 32. Now square root of x squared is just going to be x. And then square root of 32 is not a perfect square, so we're just going to leave it alone for now. We're going to have to simplify. But let's see what step 3 is. So step 3 is to simplify the radical. So here we have a square root, and then you need to place plus or minus to indicate both answers. We are going to simplify square root of 32. Okay, we're going to break this up using one of those largest perfect square that can go into 32. How about 16? 16, yeah. So we break it up into square root of 16 times square root of 2. Okay, so that makes it square root of 32. What is square root of 16? Well, square root of 16 is just going to be 4. And then square root of 2, we leave it alone, okay? And now we need to put that plus or minus, okay, in front of it. Plus or minus to indicate that you have a positive 4 square root of 2. And you have a negative 4 square root of 2. Okay, so let's take a look at another one here. So we're going to solve this by taking square root just like we did with the last one. And we're going to go through it step by step. And we have a procedure of how to do that. So let's take a look at step 1. So step 1 is to isolate x squared. So we're going to get x squared all by itself. So that means we have to get rid of the minus 7. And then the multiply by 1 over 4. So how do we get rid of the minus 7? How do we make it completely go away? Well, to make it completely go away, you would want to add 7. So we're going to add 7. Okay, because negative 7 plus 7 is 0. And then we're going to add 7 to this side. Whatever you do to one side, you have to do the exact same thing to the other side. All right, so we're going to bring down the 1 over 4x squared. And then negative 7 plus 7, they add up to 0. And then bring down the equal sign. And then 25 plus 7 is going to give you 32. So here we're not done with step 1 yet, because we're still trying to isolate the x squared. Okay, so here you have a multiply by 1 over 4. To get rid of 1 over 4, okay, to make it cancel, you can just multiply this by 4, right? Because 4 over 4 equals to 1. And then if you multiply this side by 4, you have to do the same thing to the right hand side. Multiply by 4. Okay, so 4 over 4 is 1, so you're left with just x squared. And then here you have 32 times 4. That is going to give you 128. Let's take a look. So it looks like we isolated the x squared. We got the x squared all by itself. Okay, so we're done with step 1. Okay, step 2 is to take the square root of both sides. Okay, so we have to take square root of x squared. So we're going to do that, because to go from x squared to x, okay, we need to take the square root of it. So square root of x squared, and then here square root of 128. Okay, so square root of x squared is x. And then square root of 128 is not a perfect square. So we're going to have to simplify that. So that means we have to break it up, okay, using one of those perfect square. And you want to use the largest perfect square that can go into 128. 128, how about we use square root of 64, okay, times square root of 2. And then square root of 64 is going to give you 8. Square root of 2, we leave it the same. And then, what do we have to do here? With step 3, we have to simplify. We did that. Okay, we went ahead. Sorry. We simplify the radical. And then now we have to place the plus or minus in front of the 8 square root of 2, right? To indicate that you have a positive 8 square root of 2. And then you have a negative 8 square root of 2. Okay, and that's how you do it. Okay, so let's take a look at another one. Solve this by using the square roots method. So we're going to solve this by taking square root. Okay, notice there's no bx term, so we can do it. See how you have the x squared term. And then the 4 is the constant, and then the 140 is also the constant. So no bx term, and yes, you can do this. You can solve this by taking square root. Okay, so let's take a look at step 1. So first thing we have to do is isolate the x squared. Okay, we got to get the x squared by itself. That means we have to get rid of the minus 4 and then a multiply by 3 here. Okay, so to get rid of this minus 4, you need to add 4. Okay, because negative 4 plus 4 is 0. And then we have to add 4 to this side. Okay, so we bring down the 3x squared. And then negative 4 plus 4 is 0. So those are gone. Bring down the equal sign. And then this makes 144. And then here we have a multiply by 3. So how do we get rid of it? So how do we get rid of multiply by 3? We would have to divide by 3. So if I divide this side by 3, I gotta divide the 144 by 3. So 3 over 3 turns into a 1. So 1x squared is the same as x squared. And then 3 goes into 144. So it's going to be 4, 12, 24, So 48. Okay, so 3 goes into 144 is 48 times. So this is step 1, isolate x squared. So we got the x squared by itself. Let's take a look at the next one. Take the square root of both sides. So we're going to take the square root of x squared to get rid of the square. See the square up here? So take square root of it, square root of x squared, and then take square root of 48. Okay, so square root of x squared is x. And then square root of 48 is not a perfect square. So we're going to leave it alone for now. Okay, let's see what step 3 is. Okay, step 3 is to simplify the radical. So simplify the square root. And then place the plus or minus to indicate that you have two numbers. Alright, so we're going to simplify square root of 48. So we have to break down 48. Okay, using one of those largest perfect square. How about we do 16, square root of 16 times square root of 3. Okay, what is square root of 16? Square root of 16 is 4. Because 4 times 4 is 16, and then we leave the square root of 3 alone. And then we need to put the plus or minus in front of it. Okay, to indicate that you have a positive for square root of 3, and you have a negative for square root of 3. Okay, so let's take a look at one more. Okay, this is the last one that I'm going to show you how to solve by taking square root of a quadratic equation. Okay, again, you can do it to this equation because there is no bx term. Okay, you have the x squared term and you have constant and then constant. So yes, you can solve this by taking square roots. Okay, so let's take a look at step 1. So step 1, we have to isolate x squared. So we have to get the x squared all by itself. So that means we have to get rid of the positive 10. And then a multiply by 5. Okay, so how do we get rid of the positive 10? Well, to get rid of the positive 10, you do the opposite. Opposite of positive is negative, so you want a minus 10. And then here you want a minus 10. Okay, so we bring down the 5x squared. And we know that positive 10 and negative 10, they add up to 0. And then bring down the equal sign, and then 310 take away 10 is going to give you 300. So now how do we get rid of this multiply by 5? So what is the opposite of multiply? Well, opposite of multiply is divide. So we're going to divide this by 5, and we're going to divide this by 5. Okay, 5 over 5 is 1, so cancels out. So you're left with just x squared. And then 5 goes into 300 is 60 times. That's the first thing you have to do, is to isolate x squared. Okay, let's take a look at step 2. So step 2, we have to take the square root of both sides. So we're going to take the square root of x squared, and then we're going to take the square root of 60. So square root of x squared, and then square root of 60. Okay, so square root of x squared is going to give you x. Okay, now square root of 60, well, 60 is not a perfect square, so we're going to have to break it down using one of those perfect square. So the largest perfect square that can go into 60, well, that's going to be 4. So square root of 4 times square root of 15. Right? 4 times 15 is 60. Okay, that would be step 3. Sorry. Step 3 is to simplify the radical, and that's what we just did. And then we have to indicate the plus or minus at the end. So right now we're in the process of simplifying the radical. Okay, so we broke down 60 using 4 and 15. So square root of 4 is 2, and then square root of 15 stays the same. We just leave that alone. Okay, and then don't forget to put the plus or minus to indicate that you have a positive 2 square root of 15 and you have a negative 2 square root of 15. So this takes us to the end of this lesson.